why do you need coroutines with a capital C? In other words, asynchronous functions. Well, you've probably seen some code in code bases that use async IO that looks like this. You have some task, and that task runs, and you have some main, and it launches a bunch of tasks, and those tasks run. You can see here it's still running. It's just kind of laminar flow. It's kind of hit some steady state here. And you might have looked at it and said, well, how's that any better than what I did with threading? You can see here's an example with threading, and the underlying code for threading really not too dissimilar. Or how's that different than multiprocessing? Threading maybe has this problem with the global interpreter lock, but multiprocessing doesn't. What do I really need async IO for? I don't want to share with you all the details of async IO because it'll take us way longer than we have time, but I want to share with you one critical detail of async IO that comes up as, I think, one of its main motivations. Async IO, asynchronous functions, matter because they allow you to run different units of computation, not simultaneously. Fundamentally, async IO is single-threaded. Fundamentally, two asynchronous tasks can't run at the same time in a very similar way that the global interpreter lock prevents two threads from running at the exact same time. But the model for concurrency is cooperative, and the model for concurrency, it occurs within the same process. In other words, if you have some main and you have some construction of some tasks, and those tasks are adding to some shared piece of data, you do not need to serialize the data and to move it between Python processes using something like Pickle, as you would with multiprocessing, and you do not have to be aware of data hazards or data races. You do not have to worry about, if I'm putting something into this set, what happens if these operations don't occur atomically and the set somehow gets corrupted? Because in the threading model, when the individual threads run is decided by the operating system. You don't control when the threads run. The operating system does its best job to figure out how to schedule these. In the async IO model, you decide when somebody can interleave you by explicitly awaiting, which means if you have some operations that you need to do atomically around the manipulation of some shared resource, like some global state, you just do them. And then you say, interleave me. You don't have to worry, do I have to put a lock here? Do I have to make sure that somebody doesn't step in when I'm in the middle of doing something? No, you just decide cooperatively when you want to be interleaved. And that means you have to be careful, because if you don't allow people to interleave you, then you're going to block other people from running. Additionally, if it is the case that you want to share some resource between these, you want to share some resource that's not serializable easily, like a live running generator, an open file, anything that's very stateful. In the multiprocessing mode, you'd have to serialize it between one process to the other process. And you can absolutely use multiprocessing shared memory, which was added in Python 3.8, to avoid copies of that data by putting it into a shared memory block. But fundamentally, in the multiprocessing mode, the interpreters are distinct. And because the interpreters are distinct, you can't just take a running generator, a generator instance of one, and move it over to the other, because there's all this state that you'd have to move over at the same time. Whereas in the async IO, because everything's in the same process, you can move things between the individual units of computation, the tasks, very easily, because it's just the same Python process. So a generator that's running in this task over here that you move over to this task over here, well, it's the same process, it's the same program. You can easily do that. And so one of the reasons why async IO matters, and the reason why you should care about async IO, is, do you need a model for concurrency where you decide where the individual units are scheduled, where they interleave, so that you can avoid things like data hazards and locking and races? And do you want to be able to move very rich data, arbitrarily complex, arbitrarily rich data between those processes without copying it, which you'd have to do prior to shared memory in the multiprocessing, and without having to worry about, is this actually serializable?